Welcome to part 2 of the chapter 4 video on shape, center, and spread. All right, so on this one, we're going to be comparing box plots. So now I've got 3 and 1. And first thing I want to do is focus on shape. And in a box plot, we kind of focus on the median. So the median is here, and that would represent the bottom half of the data, and that's the top half. Well, they're stretched about the same. It's about the same length. So that's somewhat symmetric. And then same thing here. You look at the bottom half of the data, top half of data, other way around, bottom half, top half. It's stretched about the same. Here, even though inside the box, this part stretched out a little bit more than this part, this tail kind of makes up for it. So it's roughly symmetric. And again, here, if you look from the median to the top half of our data and the bottom half of our data, all these look roughly symmetric. So let me get rid of all those marks. Okay. And we can say all three are roughly symmetric. All three distributions are roughly symmetric. All right, center. Well, the only measure of center that we can see in a box plot is the median. Median here looks like about maybe like 3.2. Here, maybe a little bit less, 3.1. And this is the only one where there's a significant difference. And that we could call maybe 3.8. So we can say teenagers, well, let's use the word median. Okay, so median of teenagers and youth are similar. Doesn't mean they have to be exactly the same. Median of older adults is about 0.5 more than teenagers and or youth. Okay, spread. Again, we don't like to use range because in skewed data or if we have outliers, the range can be greatly affected. So we're going to focus on the IQR. Let's get rid of these marks. And for spread, again, we're going to be talking about IQR. So that's going to be from quartile 3, quartile 1. So that's about, let's call that 3.8. Call that about 2.4. Okay, so IQR of teenagers is 1.4. And this for youth, that looks like 3.8. That's just a bit higher than this one, so we'll call that 2.5. Okay. Of youth is 1.3. We could have also said the IQR of teenagers and youth are approximately 1.3, or we could say are similar, right? And now significantly different on this one. You can see the box isn't nearly as wide. This to me looks like right about 4 or 4.1. That would be your call. I'm going to call it 4.1. Wouldn't argue if you called it 4. This one coming over maybe 3.4. We'll call it 3.4. And so that's a difference of 0.7. And IQR of, what's that, older adults, we could say is about half of teenagers and youth, because it's good to make comparisons between the two. But if you want to spell out what it is, IQR of older adults is 0.7. But it's good when you discuss shape, center, spread that you compare. One is more than the other, one is less than the other. They're similar. Um, some sort of a comparison. All right. So now, something new that we haven't done before. Let's try to match these 4 distributions, these 4 histograms. They come from 4 distributions. And the same 4 distributions, we've created box and whisker plots. So now, which distribution gave us the same histogram and box plot? So in other words, if we look at this, we'll call this 1. Oh, actually, you know what? I'm going to stick with the letters that they have here. I now notice there's letters here. So we have A, B, C, D. We want to match them with those. So when I look at this histogram, I can see I'm going from 0 to 10. Well, it looks like they all go 0 to 10. The majority of my data is chunked right here, and I've got a tail going to the left, so it looks skewed. So I need something where a lot of my data is between, let's say, 6 and 10, 7 and 10, but it's stretched out to the left. All right. I'm hoping that you guys kind of see this one. Big chunk of our data is right here on the upper end. All right. Just like right here. And it's really stretched out to the left. This is skewed left. So we would say A matches 3. All right, I'm going to pause the video for a moment. You guys see if you can see what other matches you can come up with. All right, so I'm going to look at this. I'm going to look at B next, just going in order here. B. A large part of my data is on the lower end, so maybe it's this one, maybe it's this one, but this one's kind of stretched out here. What I really notice is I've got a gap here, and I have clear outliers. If we had all the correct values of 5-number summary, we could calculate to see if it works for the 1.5 IQR method, but clearly there's a gap there. And I can see a gap. This is the only one where I see a gap. And these X's, we haven't done any like this, but you can set the TI-84 to show outliers. But again, clear gap, X's marks outliers. We have outliers here. And it looks so that makes me think B is going to go with 1. B goes 1. All right, so that leaves C. We could do D next, doesn't really matter. Let's see, big chunk of data. These tall bars, histogram, we have a lot in the lower end. 2 doesn't seem to have a lot in the lower end. 4, 50% of your data, median and down, is 2 or smaller. Kind of fits. And then it's really stretched out to the right. And look, if you look at the median here, look how it's not stretched very far to the lower end. Okay, so it's not stretched on the left, but from the median to the top end, Look how stretched out that is. So I can see that's really skewed to the right. And look how stretched out it is to the right. So I'm going to match C with 4. And then D is the easiest one. Looks pretty symmetric, centered around 4, 5, 6. Here we go. The majority of your data centered around 4, 5, 6. The tails stretch pretty evenly. So D matches with 2.